So, hi everyone. This presentation is about gait gestures, examining stride and foot strike variation as an input method while walking. I'm Qingyi. I'm now from Princeton University, and this interesting work is conducted when I was a research assistant at University of Waterloo. Okay. So many people walk throughout their day, such as going to a meeting in another building, going to conference talk, getting coffee, or just enjoying trails in park. And during this walk, there's often needs to accomplish small tasks like ordering food ahead, controlling music playback, or sending short text messages. Currently, most people use a smartphone, but touch input while walking is arrow porn. And looking down a screen while walking is dangerous. So a typical strategy is instead just stop walking. And new development in mobile augmented reality avoids the need to look down at the phone screen. But using hand gestures such as pinch has been shown to be slower or more difficult to perform when you are walking. And additionally, using hand-based input may not be practical when hands are carrying something such as suitcase and coffee, or even it's not really practical when it's cold outside, like reaching your hand out of your pocket during winter in Waterloo really sucks. So in this project, we are trying to find an input modality that's compatible and native to walking itself without resorting to other modality, and more importantly, investigate its feasibility. So we started from observing that people already make a lot of deviation in their walking pattern daily, such as taking a bigger step over puddles, slowing your step at intersection, or adjust your shoes by tapping it in a certain angle. So in this deviation, we found the opportunity for an input gesture by changing the way you walk. And some of them you might already doing it daily and accepting them already. So we call this gesture gait gestures. And compared to prior work in foot-based input, they are primarily about sitting and standing at a fixed point, including using tapping, kicking, body motion, or walking in place. But since the user is not moving, this foot movement is very different in terms of body kinematic from walking, as your feet would need to move back to their origin point after the gestures. There's a work about jogging gestures, which propose the use of stepping out or skipping a step during jogging. But skipping a step during walking is hard because you don't have that much momentum. There's also a closely related work utilizing lateral movement during walking, which is not much a gesture, but more about where you walk. And this is what gait gesture look like. So the user just slow down a step and turn on the whole system. And after each normal step, the sleeves will scroll down. And how did he make a selection is by slightly touching both of his foot. I'll do this video again. So slow down a step to turn on the whole system, and normal step will turn into the scrolling of a slide. And he just touches foot to perform a selection. And now you have more sense of what gait gestures are. Some of them are more subtle like this one in the video. But definitely there are some you can imagine to be quite obvious or weird. For example, you're just walking and kicking the air and telling people, okay, I'm making order. So the question here is how to find the good gestures and whether they are feasible as AR input while walking. And to make sure we explore an exhaustive and big enough gesture space, the first approach we adapt is adapting prior gestures in existing literature to fit into walking. And when including this, we have the following requirements. The first one is physical balance. We do not require legs shifting body center of gravity, such as leaning your body leftward with one foot, which is doable when you are standing or seated but not walking. And we want to maintain forward movement, so no stepping back or no stop walking. And also, we want to maintain body support. Do not lift your both feet in the air when performing gait gestures, such as jumping or jogging. And most importantly, we want to maintain safety and ergonomic. So we want to avoid movements such as inversion or eversion that could easily induce sprain. And additionally, we also come up with some gesture by understanding human's gait cycle. And human's gait cycle can be started with a strike, which the movement your foot touches the ground. And then following that, your foot are still on the ground until a lift where your foot get off the ground. And this whole phase is called stand phase. And following by that, your foot is in the air until another strike happened. And this whole phase is called swing phase. A stride is categorized by stand phase and swing phase. So by investigating possible foot action in different stages and adapting prior work, we have this whole design space of 22 gestures. And to help you understand them, they can be categorized by whether it should be performing during swing phase or stand phase, and whether it's primarily a translational or rotational movement, along with a very special additional category that is temporal gesture. And here's some like smooth demonstration. So this one is from translation and performing during swing phase, like touch your other feet, we call it brush. And this one is stand phase translation, like stepping out, we call it tap out. And this one is performing also during swing phase, we call it swing out, but rotational. And this one is stand phase, but rotational, we call it tap rotate out. And this one is temporal, so it's like a slower step. And like, as you can see, like swing out is probably hard to perform and probably look quite awkward in a public space. So we performed a user study to understand which gesture are better and which is less ideal. We conducted a 25% formative study to let people actually work with them. And they are asked to walk on a 10-meter long, 2-meter wide path back and forth to perform each gesture 4 times, including a trial of normal walking from comparison. So the tracking device we use in this study is a head and feet with 3 vibe trackers. And that track acceleration data will be processed by a low-pass filter, followed by a pretty standard stride segmentation algorithm based on prior work. So here's all the 22 gesture. Here's the result, and you can see we put the normal walking on the top of it. The first data we collected is the perceived movement easiness by a 1 to 7 scale, 7 being very easy, 1 being very hard. As you can see, the normal walking condition on the top is always the most easy one. And also, we collect perceived social acceptability, again, in terms of 1 to 7, and walking compatibility. The interesting here is that a gesture that's more compatible with walking doesn't necessarily be perceived as easier to perform. And in terms of objective data that we just use data segmentation to get is duration, which is the time deviated from a normal walking stride per gait cycle. And one comparison we made here is that for performing gait gesture, you actually only take 100 to 200 millisecond times while walking. But to performing the pinch gesture in the air or using Gait, you actually take 5 millisecond to 7 millisecond time. So Gait gesture is comparable or even faster. And also we collect positional deviation and rotational deviation. Okay, so this is a very big graph, so a lot of interesting to talk about, but given the time, I'll just let you know how we separate the good ones out. So we performed the K-means clustering algorithm and found that there's a best category of gesture that consistently be good across the ratings, which is the gesture here on the top. And there are big step, brush, slow step, tap behind, heel, and slightly worse, but still okay, bending behind, and high step, yeah. Okay. And finally, we're going to test this Gait gesture in terms of feasibility and user experience. So we conduct a visual ops user experience evaluation to let users try using them as AR input, which we include 4 tasks, like asking them to choose and play music, ordering food, adjusting system volume or brightness, and making a phone call, or headset call, I guess, yeah. And here's some interaction we designed for some of the UI widget. The first one you have seen it. It's just navigating through a list, which each 2 normal steps will result in a scroll on the item list. As user first, changing the scrolling per step is too fast. So a normal step will result into the next item. And you can use a brush, like slightly colliding your 2 feet to make a selection. And you look like this. Make a selection. So similarly, you can use this to control a slider. While some gestures, such as bigger step or other gesture, can serve as mode switching between increase or decrease mode on the slider, and the normal step will result in interval change of the continuous value. So big step entering increase mode, and now just use decrease mode gestures. Okay, and lastly, okay, this is a pretty ugly figure, but people may ask, would you always have to use a list or scrolling with normal walking to invocate commands? So we also support the most straightforward way to utilizing gesture, which is just directly mapping them to each command. Such as you can see here, we assign each music player button with a gesture, along with some text instruction for letting user remember and directly trigger them. So the result is that the 2 main results here is we have 8 participants on gesture easiness. How easy was it to perform the gesture while walking? 1 to 7, very hard to very easy. You got the average of 6.2. In an overall satisfaction, I would like to use it for interaction while walking in the future. We got 6.9. And so we think it's promising result as Gait gesture induced. And then for the end of talk is some discussion. The first one is how do we deploy them in terms of hardware requirements. So the most straightforward way to utilizing gait gesture is using IMU sensor for acceleration data streaming on the fly, which is the data we use when testing our recognizer. But you can also utilize commercially available trackers such as Vive Ultimate Tracker that do not require Lighthouse, or even more portability. You can use you can do in future work that can explore the use of egocentric camera for certain forward gait gestures, which you can find some similar setup being explored by Vimo's talk on the next. And also the second point is learnability. So participants can now effectively learn and recall the top 7 gestures so far, but we also acknowledge that there are some effort when you are adding more variation, more gesture to it. For example, separating gesture by left foot or right foot. And since our final study is a wizard of a study, people may ask, oh, can you really recognize these gestures? So in the later part of the paper, we have tested a recognizer with a 92 accuracy of our top gestures, which is using random forest algorithm with some feature we extract from the data. And also for future work, now we're only testing straight line walking. There can also be turning around or like terrain that is not flat. And also for some of the easier gesture, you can also explore continuous gesture control, like the angle of your foot or the duration of that step to serve as a continuous input. And to conclude the talk, we believe the concept of gait gestures also demonstrate more generally how computer input can be integrated into existing primary motor tasks. In our case, it's walking, but with the goal of compatibility, not necessarily to have to be faster or efficient. And I want to thank my co-authors, Ryan Yan, Dakin, now Daisy King, and Professor Daniel Vogel. Thank you very much.
We have time for 2 questions.
Hi, great talk, Shakir from Meta Reality Labs. I was curious how, the gait can vary a lot from person to person, whether you're wearing different shoes like boots or even like high heels. The gait, the swing stage and the stand stage are quite different. And of course, if someone has a walking impediment like a cane, of course their gait looks quite different. How invariant is this sort of methodology to people with very, very different gait cycles? And like, do you think maybe even the gesture mappings or the cognitive load is different when people have different gait cycles, depending on a disability or like a different shoes that they're wearing?
Yeah, that's a great question. So, maybe you can notice that we didn't perform an elicitation study. It's a formative study. So before each study or data recording, we actually have very concrete definition for each gesture, which is in our paper, and we demonstrate them to the user. If the user demonstrates it like wrong, we'll ask him to perform like closer to our definition. And also, there's also some calibration process that will help. For example, we check we measure the length of your stride, which is normally the standard way you do to doing stride research. And also, we calibrate the tracker's position. That will help. And I think the main reason why our final recognizer work is our final 7 gesture is not really a big gesture site. And also, there's those gesture, some of the gesture can be easily tracked by other way or just a threshold. For example, touching 2 feet is actually easy to track. Yeah.
Thank you.
Hi, Ching. Thanks for the great talk. I'm Nathan from Carnegie Mellon. I'm interested, did you look at any way to track intent of the gait gestures during your study, or do you have any ideas for how you could do that? I'm imagining like I'm walking down the street listening to my favorite song and like, oops, I'm about to step in some bird poop. So I like slow down and it causes the song to skip. Like, I didn't mean to do the gesture, but I like accidentally did a gait that caused it to happen. And how could you track cases like that or solve potential problems?
Okay, thanks for asking this question. So far you can see we have designed a gesture that's about turning off the whole system or turning off the whole system. So as I said in the beginning of our talk, some of the gestures you're already performing daily. So we want to avoid false positivity. And so far our solution is just when you want to use gait gesture, turn off the system or turn it off. So there's most switching to avoid this. But I think for some gesture, because it's like less frequent, you can definitely just detect it all the time.
Yeah. Okay, thank you.
All right, thank you. Let's thank our speaker again.